Hello everyone, Advik Yadav. I'm back with another video today. So, in today's video, we are gonna discuss the concept of impulse, what impulse really is, and how it's gonna be there, what it really means, and how it's important for us in EGU perspective. Okay, in EGU perspective. Let's start. Impulse. I would like to, at first, let's start by some visualization. Okay, how do you think that impulse really would be? What sense you are getting out of the word impulse? Okay, impulse. And for a general person, impulse would really talk about like the heart impulse, the impulse pulse going inside your hand, which you measure. That's gonna be pulse. So it's gonna be like something which is very rapid. So pulse is very rapid. Impulse is in the same way very rapid, you know, a very rapid thing. As your pulse is very rapid, something pulsating is something rapid. So this is what impulse force is. A large amount of force, okay, acting on an area. Let's just take the color, change the color here. Acting on an area for a small duration of time, like t small, very small, which is equals to dt. Okay, dt. So dt is one differentiation unit, which is really just some very small interval of time, which is very minute, which is nearly equal to zero, but it's very minute. So this large amount of force, which has high magnitude, acting on this area for dt time. That's really impulse. Something very big, rapidly applied on something for dt time. That's really what impulse is. For example, force exerted by a bat while hitting a ball. So let's just say there's a batter here. Our batter is gonna look so good today, I know. There's one batter, Virat Kohli. Virat Kohli. And he is holding a bat. Oh man, I don't know how to draw a bat. Okay, he's holding this bat, and it's of MRF, MRF bat. As the bowler bowls, the ball is gonna come here, and as soon it hits the bat, there is gonna be high amount of force exerted on the ball for some amount of millisecond, which really changes the trajectory of the ball, which is out of the boundary. Sixer. That's great. So this is what it is. Impulse. There's a high amount of force, which is in this case exerted by the bat, and then transferred into the ball in dt time. Is what really impulse is. I guess it's super clear now what impulse is and what really impulse stands for. We discussed the force in the previous video, that's why I'm discussing it here. So impulse is I. Impulse is denoted for a while. Impulse. Usually it's denoted by J. Okay, J. Keep in mind. Is equals to force into time. Force here is amount of force applied and for how much time. SI unit of force is gonna be Newton and time is gonna be in seconds, most probably. Now, what we have. Now there's some interesting thing happening, which is known as impulse and momentum. And momentum theorem. So there is some relation between impulse and momentum. there's some relation between impulse and momentum. Okay, let's just see what that relation is. The impulse of a force, let's just repeat, impulse of a force, which is J, is equal, okay, to the total change in momentum produced by the force. Change in momentum produced by the force. Okay, now we can do a lot of things here. Let's just say there was a ball here and a ball of same mass here. Same mass. Okay, mass m, mass m. Perfectly fine. But the velocities are varying, u1 and v1. So u1 is less than v1, but the mass is equal. Okay. As we studied in the previous class, that momentum is basically equals to mass into velocity. Mass into velocity, we can also say mass is constant in both the cases. If we need to find out the change in mass, like say the momentum at this point is equal to the momentum at this point. Is it true? No, it is not. So what we really are finding out here is the mass is constant. Mass is constant. So as mass is constant, velocity is varying. Not because the mass is constant. It's just given to us that mass is constant for this scenario. It's not given, it's pretty understood that if you apply some amount of force on this object, okay, if you apply some amount of force on this object with mass m, it's gonna move. It's gonna move. And this force could be an impulse force. Okay, impulse force. Impulse F. So let's just say 1 second ago this mass had a velocity u1 at mass m, and after 1 second, when enough time had gone, this mass moved. This is whole 1 second timeline. This mass got a velocity of v1 and mass m. Mass is going to be constant, and there's gonna be no impact of force on the mass. So what here we can see is that change in momentum. The momentum is mass into velocity, okay? And this mass into velocity. If we subtract these two things, mv1 minus mu mu1 is going to give us impulse, okay, which is denoted by J. So if you take the mass out here, it's gonna be final velocity minus initial velocity gives us this thing, our J, which is the impulse. I guess it's clear now. Okay, so let's say force and time diagram. This graph is gonna be of force and time. Force is constant, but the time is increasing. Okay, when force is constant, which is the amount of force which is acting on the object is constant, say, which is, so let's say if v meter per second is, sorry, v newtons of force is applied, is gonna be v newtons. So the time is only increasing, but time is only increasing, but the force is not. So the area under this graph, which is this area, okay, let's just do this like that. So the area under this graph is going to be our impulse. This area, let's just say it is 4 here, and it's the origin here, and it's gonna be 4 also here. So this length is gonna be of 4 units, and this length is going to be same, 4 units. If we need to find out the area of this thing, it's gonna be 4 into 4, which is gonna be equal to 16. 16. Now what? We just forgot the unit. What unit do we use? Try to like we have kg here and meter per second here, the same unit as our that momentum. Okay, kg ms. So it's gonna be of kg ms. Got it. Kg ms. And now this is pretty simple. You can just find out with the area under the graph. Okay. Now the next scenario comes up is when we have varying force. The amount of force is varying. Let's say it's different on this point, different on this point, different on this point, different on this point, different on this point. Okay, the amount of force is really varying. It's not constant like in this one. Okay, so we'll just draw a force here and time here. Got it. Now what? As the force is varying, the area under the curve is going to be, this whole curve is going to be impulse. Okay, so we can find out certain methods. We can use certain methods to find out the area under this curve, okay, which is integration of 0 to t, which is equals to f dt. It's gonna be a hell lot of pain in the ass for solving this question, but not an issue. So what we are essentially trying to explain here, force of f and t graph gives us this thing, impulse, which is denoted by J, our best friend. Let's say J, our best friend. J is gonna be our impulse. Impulse. Got it, man. Woohoo. Now what? Nothing else. I guess we can stop here. Now what? Nothing is left. Thank you, everyone. Have a good day. Great.